Today, exponential growth and decay questions 10 to 14. So for your first question, Mr. Panalosa invested 3,500,500 pesos compounded continuously for 3.5% annually in 2018. How much will be the money now at the bank in 2025? So our given is this. Our initial value is 3,500,500. Our K or our rate will be 3.5% or 0.035, and our time will be 7 years because it ranges from 2018 to 2025. So based on the problem, we were given the growth rate, which is 3.5%. So we will be using the growth formula. So we plug in our given, so 3,500,500 multiplied by Euler's number raised to 0.035 multiplied by 7. And we'll get 4,471,674.596. So that'll be the money at the bank by 2025. Panda is an endangered animal. Their population today is around 1,900. If their population growth rate is 1.7 per year, how many pandas will there be after 25 years? So this is our given. Our initial amount is 1,900 pandas. The growth rate is 1.7% or 0.017. Our time will be 25 years. So it's already indicated here, growth rate, so we'll be using the growth formula. So we plug in our A's of 25. So 1,900 multiplied by Euler's number raised to 0.017 multiplied by 25. So we will get, when we round off the number, we will be getting 2,906. So there will be around 2,906 pandas after 25 years. Now, a gaming computer valued at 55,000 pesos depreciates at a certain rate. If after 4 years the gaming computer price is 32,500, what is the depreciation rate? So since it's looking for the depreciation rate, it means we'll be using the decay formula. And also we can tell from our values here, ranging from 55, and then after 4 years it becomes 32,500, meaning the price of the gaming computer goes down, meaning we'll be using the decay formula. So our initial value is 55,000, our time is 4 years, and our base of 4 is 32,500. So we use the decay formula. It's the same as our growth formula, except our rate is negative. So we plug in our value, so 32,500 is equal to 55,000 multiplied by Euler's number raised to k, since our k is unknown, times 4. So to isolate our negative 4k, we'll divide both sides by 55,000. So this will become 13 over 22. Now, to fully isolate our negative 4k, we also have to get rid of the Euler's number. So in order to do that, we will use natural logarithm, or ln. So ln of 13 over 22 is equal to 4k. Since we use natural logarithm, we got rid of the e, and the exponent of negative 4k becomes our value. So to isolate k, we divide both sides by negative 4, and we'll get our rounded off value will be 0.1315. So the depreciation rate of the gaming computer is 13.15%. A bacteria is placed in a favorable environment. If there are 950 bacteria to begin with, and 12,400 bacteria in 2 days, how many bacteria will there be after 2 weeks? So for this question, we're looking for two things. In order to get the bacteria after 2 weeks, we must first look for our rate. So our given is our A sub 0, our initial amount, and also our A sub 2, which is 1,400, because that's the number of bacteria after 2 days. So we'll use this given in order to find our rate, in order to look for number of bacteria after 2 weeks or 14 days. So we do the same as what we did earlier. So we plug in our values. We'll be using growth formula because from our values we can tell that the number of bacteria 950 went up after 2 days, so it became 12,400. So we'll plug in our values. So 12,400 is equal to 950 multiplied by e raised to k multiplied by 2. So in order to isolate e raised to 2k, we divide both sides by 950. We'll be left with 13.0526 is equal to e raised to 2k. Using natural logarithm, we divide both. This becomes ln to 13.0526 is equal to 2k. So divide both sides by 2 in order to get our k, and we'll get approximately 1.284. Now, in order to get a more accurate answer in the number of bacteria, we'll be using this unsolved formula. We'll be using this equation. We'll plug in this answer instead of the rounded off version in order to get a more accurate answer. So we use the growth formula again, but this time with our rate. So our A's of 14, we're looking for our A's of 14 because that's the number of days after 2 weeks. So 950 multiplied by Euler's number raised to ln of 13.0526 over 2 multiplied by 14. And we round off we round off a number and we'll get 6.5 multiplied by 10 raised to 10. So that's approximately 61 billion. So there will be approximately 61 billion bacteria after 2 weeks. For our last number, carbon dating is used to determine the age of artifacts. Carbon-14 is used in the process of carbon dating. It has a half-life of 570 years. What is the rate of half-life per year carbon-14 has? So for this number, we're also looking for our rate. So our given for this number, our initial amount is 1 because it isn't given. So we assume that it's 1. Now for our time, it's indicated here 5,730 years. And our B's of 5,730 years will be 1/2 because it's indicated here half-life. So for this number, based on the question, we'll be using the decay formula. So using the decay formula, we substitute in our values. So E becomes just the Euler's number because it's multiplied by 1, which is just the value. So 1/2 is equal to E raised to negative 5,730k. So to get rid of the E, we use our ln, divide both sides by 5,730, and we'll get 0.00121 as our k. So the rate of half-life per carbon-14 has approximately or around 0.0121%. Thank you for listening.